laptop. Okay. All right, we're live. This is group 7, lesson 10. All right. So any questions on part 1?
No.
Nope. All right. Yeah, one of the confusing things, Carrie, is that we learn different things and then they'll change the name. For example, the mean in this lesson, the sample mean becomes the, what do they call it? The point estimate.
Well, I saw that, and then also, well, and then in that little underneath the point estimator section, so 3.1, it started calling the mean of the population the population parameter also, like.
And that was actually back from lesson 2 or something like that, where they were like, this is the population parameter and this is the
I don't remember calling parameter.
I know. I had to go back there and look at it because I was like, what are you talking about? All right, well, part 2, let's start with 6. It says, what are the 3 assumptions that need to be checked before you compute a confidence interval for a mean?
Okay, I can answer that one.
Go for it, girl.
Some of the others I can't, but I can answer that one. Population. You have to have a distribution of sample which is normally distributed, and you have to assume that the standard deviation is known.
Yeah. So the first one that was a little bit hard to understand, it has to be a simple random sample of the population. Okay, good. So those are the 3. Okay. Wait. Yeah. All right. So the Graduate Management Admission Test, GMAT, is used as an admission criterion in many Masters of Business Administration programs. A BYU professor would like to estimate the population mean from a simple random sample of 50 people's score. The sample mean for these students is 541. Assume a population standard deviation of 32. Answer the following questions. So number 7, what is the point estimate for the population mean?
That's 541. It's the same as the
Sample mean.
It's the mean.
Yeah. So point estimate and sample mean are the same thing. So 541. Yep. Okay. And then at number 8, it says create a 95% confidence interval for the population mean. Show all your work. Okay.
Sure.
Hey guys.
Hello.
Hey, how's it going?
Good. How are you guys?
Good. So we're on question number 8 on part 2 of our homework assignment. So it's having us create a 95% confidence interval for the population mean. So in order to do that, you take the sample mean and you plus and minus it by the margin of error. And so we can actually solve first for the margin of error, which is the z-score of the 95%.
So, well, okay, so it says when you know the little Q thing.
Yeah,
so it says
that
last sentence says assuming a population standard deviation Q of 32. Answer the following. So 32 is not that. Okay.
That's the standard deviation of the thing, because we have to they're telling us that in real life we wouldn't know it most of the time,
right,
but they're going to give it to us. So that's our standard deviation. So you'd have the z-score of 95%, and you could either use the applet, but they give us what the 3 most common, which was 90%, 95%, 99%.
right.
So it'd be, we're trying to find the margin of error first, so that would be 1.96, because that's the z-score of 95%, times the standard deviation, which is 32, divided by the
square root of
the square root of 50, because they took a sample of 50 people's scores. So I have to get my trusty calculator out. Where is it? Okay.
Well, you get the square root of 50 is 7.0710.
Okay.
So you divide that into 32, and it comes out to be 4.5255.
4.5255, and then times that by 1.96.
Comes out to be 8.869.
Sorry, say that one more time.
8.86.
8.869.
Well, would it be 8 point? If we round, do we round up at this point?
Not yet.
Not yet. That's what I thought.
Yeah. Yeah, I wouldn't round it until we're ready with the answer. So then what you would do with that 8.869 is you would take, because we want to find the confidence interval, so we want to find the high and the low, you would take 541 minus the 8.869, and then and that's your first number, your low number,
It's
which I got.
532.13.
Okay, that's what I got, 532.13. And then you would take 541 and add it to 8.869.
So the plus and minus is the 32 to the 541, correct?
The 32 divided by the square root of n.
Yeah.
Wait a minute, I'm confused.
Okay, so the formula is you take the sample mean.
Right.
So you've got your
The sample mean of 50, right?
no, our sample mean is of the 50 students is 541.
Okay, that's what we're working with, the 541.
Yeah, so 541 minus the z-score times the standard deviation divided by the square root of 9.
Which?
And then you would do it again, 541 plus the z-score times the square root divided by this, the standard deviation divided by the square root of 9. Which?
But we already worked out the 32.
The margin of error, right?
Oh, that's
it's the margin of error. If anytime you'd have that z-score times the square root divided by the, or excuse me, I keep saying that, the z-score times the standard deviation divided by the square root of n, that's called the margin of error. So you would take the sample mean minus and plus the margin of error to get our confidence interval. So when we take the 541 and plus it by our margin of error, which was 8.869, I got 549.87. I think that's what I wrote down.
Yeah, that's what I got.
Is that what you got?
So that is what we're plugging, the 8.8699, that is what we're plugging into this equation, right?
Yeah, it's the margin of error. That's what we figured it out, the margin of error to be.
That's what I thought. Okay.
Okay. All right. Any other questions on number 8? Okay.
And is this the type of problem, you know how in the reading it said you can't have, you'd round it up to the whole number?
No, that one will be when they want to know what the sample size.
Oh.
Yeah. And that's number 13 on this lesson. We'll get to that. So number 9 says, say that the sample size changes to 100 and then compute a 95% confidence interval with the same point estimate. So you would do the same thing except change the square root of, the margin of error would change. Yeah.
So you'll get a 6.272.
For the margin of error?
Yeah.
So you said a 6.272?
7.
Yeah, that's what I got.
Okay. So if we minus 541 by the 6.272. I got 534.7. Okay, this is what's funny is on the answer they actually rounded it now to the third decimal, so it was 534.728.
Yeah.
Okay. And then for the higher number, it was 541 plus the 6.272. I got 547.272.
Okay, I got that.
Okay. And then 10, it says, how does the margin of error for the 95% confidence interval of sample size of 50 compared to the margin of error for the 95% confidence interval of sample size of 100?
Well, is it considered larger? Because it's a
The
6
sample
point.
size is larger.
Yeah. When the sample size gets larger,
The margin.
then the margin of
smaller.
the margin of error gets smaller. And so the larger the sample size you get, the closer to the true population mean you get. You're kind of closing in on it. So that's why when we increase the sample size, our margin of error got smaller. It went from 8.
I'm a dork. For some reason, I was looking at 4.5. Yes, it is smaller.
You're fine. I have to sit there
you
and
guys
think through the process.
I really am a blonde. Sorry.
No, you're good.
No, it doesn't matter your hair color. There are times that I go through these and go through them and go through them and go through them, and I finally just look at it and go, I don't know what this is. I'm going to have to start all over.
I know.
I don't know what it is. I could read this and read this and read this, and it does not make sense. But as soon as I start talking, like getting like, we just need to work together all the time.
I agree.
I actually did the homework quiz already for this, and I missed one question both times. And it wasn't until after I went, "Oh, you're an idiot," that you knew the answer to that. I was like, ah, and it was one of those where it said it normally distributed, in that little hidden in a thing, and I was like, oh. Anyway, I was like, you're stupid.
All right. Not. We're just hard on ourselves.
I know we are. Like, who cares, right? C is passing. C is passing.
That's right.
All right, 11. Create a 90% confidence interval for the original 50 students. So
it's the same thing, except you're using 1.645 as the 90%.
Yeah, so you change the z-score in that margin of error calculation. And so let's see.
32 minus the square root of 5 minus 7.
Oh.
Wow.
Okay. Sorry, say that again, Chris. We kind of chopped up there. Are you still there, Eduardo?
Yeah, I'm here.
Okay, awesome.
When you get to the 32 over the square root of 50, you come out with a 4.5255, then times that by 1.645.
Okay.
So it comes out to be 7.444. And then you plus or minus it again.
Okay. The answer I got for the interval, so the 541, yeah, anyway, we do the same thing. It's 533 point, I can't read my own writing, 566 or 56?
556.
Okay, 533.556. Number 548.444.
Yeah, that's what I got.
Okay. So then 12 says, how does the margin of error for 95% confidence interval that you computed in question 8 compare to the margin of error for the 90% confidence interval that you compute in question 11?
It's the same. The margin of error gets smaller as the sample gets bigger. Oh, wait a minute. No, that may not be right.
Yeah, so our z-score got larger. So when the level of confidence, which is kind of what the z-score is, when the margin of error will get smaller as the level of confidence grows smaller. So we decreased our z-score, and that's why it got smaller. Okay. Does that make sense to everybody?
Yeah.
Mm-hmm.
Okay. All right, 13, the BYU Idaho professor would like to repeat the experiment, but he wants to make sure he has enough students in his sample to ensure that his margin of error is 5. How many students will need to be in the sample to ensure he has this level of accuracy for a 95% confidence interval? So this is the one, Carrie, where you round it up to the whole every time.
Okay.
And so the
This
formula
is
for this
is the formula. I think that's n equals the
Z
z-score
times
the standard deviation over the
M and then squared.
m squared. Yeah.
Yeah. And I always forget. That's what I find I was doing, was I kept forgetting the square. So be careful. If anyone's like me, be careful. Just make sure you square it.
So with and then we just kind of collect data and then plug it in, right?
Yeah. So what would the z-score be for this one?
1.96 because it's 95%.
Yeah. It's that 95% confidence interval. And so the z-score would be 1.96.
And then the Q is the sample mean, right?
It's actually the standard deviation.
Standard deviation. Oh,
yeah.
Deviation.
Yeah, you're fine. And then divide that by
M, which...
Yeah, go ahead.
Margin of error, right?
Correct.
So we have to go back. So, so we technically use that margin of error that we got, the 8.8699, right?
Well, yeah.
You could, but he actually gave us a margin of error because he wanted to make sure that that was the margin of error. So if you look up in the
that's right.
13,
He said he's trying to solve for 5.
Yeah. Yeah. So it makes it pretty easy. You times 1.96 times 32, which is 62.72. Divide that by 5, and then square it. And I got 157.35, which pushes it up to 158.
Because you can't have partial people. Huh.
Yeah. So we'll just make extra.
Like the whole 2.5 kid average.
Right. Exactly.
Boy, does that create a problem.
That's probably the easiest formula out of all of them.
It is.
When you can remember the square.
Yeah. If you don't remember the square, you're messed. Okay. So we're done with that. Let's move to the quiz.
Okie dokie.
Let's do it.
If my quiz will open up. Come on, baby. Open up.
It's going to be like, you already submitted it.
Exactly. I hate you. You don't get to take it. Seriously, I had it open. Why is it being so stupid? Okay. Okay. There's my quiz. Open up. All right.
So, true.
Yay.
It's so random. Some of these quizzes are 9 or 10, and then some of them are like, oh, let's give you 30. Yeah.
Yes. Exactly. And they only give you 0.5 credit for half the questions. And I'm like, okay. Just tells us to remember, don't round anything until, okay. Question 3, find the margin error for a confidence interval, 90% confidence interval when the standard deviation is 50 and the sample size is 25. So our formula for margin of error is Z, which for this would be 1.645, I believe, right?
Times
Okay.
the standard deviation, which is 50, divided by square root of 25.
Correct.
Yeah, which is
Okay.
5.
It's nice of them
That's
to give us
10.
nice numbers, yeah.
I got
And times
16.
I got 16.45.
times 10. Yep, 16.45.
Yeah.
But you bet it's 0.
But
Okay.
it says round it to the 3 decimal. How dare they? 16.450.
That's what I put.
Okay. Yeah, because I got the same thing by 5 times 1.645. Okay, yep, I'm good with it. Okay.
Okay, number 4. Which of the following statements is true? Standard deviation squared is an interval estimator of, isn't that the sample mean?
No, it's at B because that's the sample is the point estimator of the population.
That's what I thought.
Yeah.
Isn't that back to like a couple lessons ago where they always equal each other?
Yeah,
Exactly.
exactly. They equal, but they're not really. We actually really don't know what the true population mean is.
They just make this stuff up. And then they're
I
like,
know.
learn it.
Remember this. All right, question
And
5. Gina
All
wants.
right. So what was number 4? Was it A or D?
B like boy.
Oh, be like boy. Okay. Okay.
Yeah. They're just saying the sample mean is now called a point estimator, so it's a point estimator of what the true mean would be.
Gotcha.
Didn't their mom say it's ever rude to point at people?
That's right.
Okay, sorry. So for
Gina wants. Go ahead.
go ahead. No, go ahead.
No, really, you.
Okay. Well, I was just gonna say 95%. The 95% confidence level is the 1.960.
Yeah.
But okay, so interval for GMAT, she knows the standard deviation is 113 divided by the square root of n, which is 64, and computes the mean equals 526. Use this information for the next 6 questions.
Wow.
Sweet.
All right, so what is the point estimate for the true GMAT score? Wouldn't that be what X is, the 526?
Yeah.
That's what I thought.
Yep.
Is that what you got, Chris?
yes.
All right. And then what is the margin of error for the 95 percentile or whatever? It's not percentile. I don't know why I add that in. So that's
It works.
That's okay. At work, I kept saying, we can fax that receipt to you. And they're like, what are you talking about? I'm like, oh, I'm like creating new things for us to do.
Oh, that's pretty funny. All right. Whoops. Yeah, so we find the margin of error by using that z-score times standard deviation divided by square root of n.
So did everyone set it up as 1.960 times 113 divided by the square root of 64?
Yes.
Okay. So I got 0.48047685.
Let's see. Yeah, let's see. I got 14.5 because the square root of 64 is
8.
8. So
Okay, my calculator is not doing this right. Okay, so 113. I must have hit something wrong. Divided by the square root of 64. Oh, you got 14. Okay, 14, and then you times it by the 1.96, right?
Yep.
1.960. Oh, 27.685.
That's
Wow.
what I got.
I don't know where that other answer came
Do they
from.
want us to round to like the third or something?
Yeah, we always round to the third unless we're told otherwise. Which
So,
this one?
so we just put the whole answer?
Yeah.
5.
Yeah.
Okay, and question 7 says, what is the lower limit of this confidence? So now we do that split.
Yeah. So now we know the mean is 526. And then so we minus that by our margin of error, which we got was 27.685. And then also add it. Well, I'm sure they'll ask us to add it, but yeah, so 526 minus 27.685.
So did everyone get 498.315?
I did.
Okay.
What did you get?
5?
I got
98.315.
Oh, 0.315. Okay, yeah.
Okay, so I didn't hear it. What did you get?
498.315 for the lower limit.
Okay.
And then the next question asks us the upper limit. So that's 526 plus 0.685. I got 553.685.
Now you're pixelating a little bit.
Am I?
Yeah.
Just a little bit. Not now.
Okay. I got 553.685.
That's what I got.
Okay.
0.685?
Yeah, 553.685.
Yep.
All right. Okay, and it says, what would happen to the width of the confidence interval if Gina increased the sample size?
It's going to decrease.
I agree. And to think of it in a math term, it's because if you increase the sample size, it creates a larger denominator, which then decreases that number as a whole.
So what would happen to the width of the confidence if changed to a 99% confidence interval? Because we just did the 95, right?
Yeah. So it increases the z-score.
So you're going to increase the width of the confidence interval.
Yeah, I agree. Yeah, if you increase the confidence interval, which is our z-score, you're going to increase that width. It's going to be bigger. And the way I remember that is it's creating more area under that bell curve. And so you're pulling out the numbers, the data, when you increase that. Okay. Question 11, Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence level, which is at 1.960, with a margin error of 50 hours. What sample size do they need?
Okay.
So that's that easy one.
So it's the 1.960 times the 400 divided by the margin error 50 squared.
Squared.
Yeah.
Squared.
Make sure I got
Squared.
that.
960 times 400 divided by 50 times 6.
Then we have to remember to round that up to that whole number.
So I got 246.
I agree.
That's what I got too.
Yep.
Sweet. All right. The mean salary of actuaries is $100,000, and the standard deviation is 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis, I can't say that, hypothesis test with a level of significance 0.5. So the null hypothesis equals 100,000, and then we're just trying to see if it's different, so it's not equal to our alternative hypothesis is different. So you collect a random sample of 36 women's salaries to find that the mean is $111,000. All right. So now we get to answer.
See, this is another one example of them giving more information than you really need to.
Yeah, that like scares me, and then I'm like,
And I'm like, oh, it's just a sample mean, and like, I'm with you. It was like scary. That looks scary.
Yeah. Well, let's try and figure out. They want to know the confidence level of this hypothesis test. So of 95%, we know the z-score is 1.96. So just looking at it, I think we just take the mean, which they found out was 111,000, excuse me. And then you're going to minus it. We have to find first the margin of error. So that would be the 1.96 times, they said the standard deviation is 36,730 divided by a sample size of 36. What?
The standard
So
deviation is 36,730. I'm going to divide that by the square root of 36, times it by the 1.960,
Yeah.
right?
Yeah. So,
Yeah, okay. I didn't see that one up there.
so the square root of 36 is 6. So 36,730 divided by 6.
So I got a z-score of 11,998.46666.
Our margin of error. Yeah, so you're going to take 111,000 minus 11,998.4666 on and on. So, I just typed it wrong. Minus.
So did you guys get 99,000 and $1?
Yeah.
54.
So they want us to round to,
99001.
and they want us to round it to the nearest whole number. So I would say,
Maybe 99,002.
yeah.
So it'd be 99002, right?
Yep. Yep. Do you guys ever put the commas in for that?
I was about to ask you that right now.
Well, I won't, and we'll see what happens.
I don't think they want you to.
Yeah.
So wait a
I
minute, you
think-
took the homework quiz, but you haven't done the meeting quiz yet? Is that what you did?
Yeah. Yeah.
You're a crazy lady.
I know. I should have waited. Maybe I wouldn't have missed that one problem.
You got in
Okay.
this class already.
So now it wants the
No.
upper limit. So then
Yeah.
we just add.
Yeah. Okay, so then I just add that number, 11,998.46666, whatever. Okay. Which I got to be 122,999, because they want us to round it to that
Right.
whole number.
That's what I got.
Okay.
What was that? Just to make sure.
122,999.
So 122,999.
Oh, wow.
Yep.
If we're not, I don't think we're supposed to put decimals or anything.
Yeah.
Or
Yeah.
commas.
Commas. We won't, and then I'll turn it in and see if it happens. There are 3 requirements that need to be checked when computing confidence interval for a mean. They are.
It's all of them.
Oh, yes, it is. I was checking them all off, but no, you can't do it.
Yep, it's all of them.
Yep. All right, I'm going to submit it.
Oh, hold on.
Let's see what happens.
Wait a minute. Are we
Yes.
missing? Am I missing? What's the last 14?
It's all of the above.
All the above. And what was 6?
6 was 27.685.
Okay, just making sure. And then number 10 was no change, right?
Increase.
Oh, increase. Okay. Thank you, guys.
Mm-hmm.
All right, we did it. We got 100%.
Yay.
Yay. We rock.
Woo, woo.
Can we just do this for homework?
Okay,
That's right.
compared to my project management, I never thought I'd say, hey, biostatistics is way better than project management. And I said that today. I'm like, I'm
That's
doing much
funny.
better in my biostatistics. Thank you to you guys. So thank you.
Oh, good. No, we make a good team. All
Well,
of us.
seriously, this class is the first one where the team literally makes or breaks it. Because
Yeah.
we've had squat from our teacher. Sorry, teacher, if you're watching this.
It is. You feel very isolated. Well, I'm glad I got paired with you guys. It was good.
It was.
It really is good.
Well, I have to say, I prayed a lot over this class before it started. So they're all answers to prayers.
Oh, good. You got us going.
Oh.
All right. Very cool. Well, thanks. That was simple.
Yay.